Good morning. My name is Stan Bissinger. I wanted to talk to you today about sodium ion batteries for grid storage. Um, the uh, the components to this story have several advantages. There's the issue of cost. Sodium is much more available, doesn't have the ethical issues going on with it that lithium and cobalt and nickel have, for example. It's going to be able to solve the temperature issues that you have with lithium in terms of its not particularly good performance in cold and hot weather. It's going to be capable of charging faster and holding a charge and giving you more cycles and so on. I did a little quick study on this. There was a program I saw on YouTube several years ago given by Jack I trying to think of his last. He's the guy that does the EVTV. Ricard. I think his name is Jack Ricard. And he has a presentation where he was describing the problem with the oil companies in regards to new technology. And I have two slides from this I'm just going to show real quick here. Stanford Oshtenke, inventor of the nickel metal hydride battery, died in 2012 at the age of 89. Can you guys see this? Still deeply embittered by what General Motors and Texaco, later acquired by Chevron, had done by this baby, to his baby. It was its greatest potential use in the use of Oshinsky specifically developed it for. It was never realized. They simply bought it and shelved it. Does that make sense? To spend hundreds of millions of dollars to acquire a promising technology and shelve it, not to worry at all about selling it to the products from it, just park it.
The car companies and oil companies have done the same thing with many other products too, to sell more oil. They've bought carburetors that were developed that had much higher mileage and to keep them out of production,
Yep.
among other things.
Yeah, it is easy to pick on big oil because they're so pickable. I mean, they're such a huge target. But I think other companies do this in cutthroat world too. And Silicon Valley probably does some of that, where they might buy something, acquire it just so a competitor doesn't get it. Google or something, or they, something that might compete with them. So but yeah, oil is well, they know who their enemy is.
So Texaco bought the entire Ovinix nickel metal hydride battery business from General Motors with its patents, of course. They allowed this battery chemistry for camera and laptop batteries, but specifically refused to license it to anyone in larger sizes suitable for electric cars, and that continued until the patents ran out. By then, it didn't matter. The lithium battery was the ascendant, but they absolutely delayed the development of electric cars by many years. So
yeah, this sort of behavior has been done a lot, but there are occasional places where the technology gets applied without having the proper patents or licenses.
All right, my hand is up, Stan. I have a question.
yeah, go ahead. Let's talk about that video.
Yeah. Well, one thing, the lithium, all the lithium is in Bangladesh or wherever the hell. No, it's 20 miles away and 50 miles away in the Imperial Valley, underneath the Salton Sea. There is proven enough lithium to replace every lithium ion battery in the US and Europe and maybe on the world in the world right now. The problem is, how do we get it out of there environmentally, et cetera, et cetera, et cetera? But it's there and it can be had. All right, my other question was, that's my comment. My question is, I still haven't seen a number. Well, sodium's a little heavier. How heavy is a little heavier? Is my 4,800 pound car, little small SUV, going to be 6,500 pounds? How heavy is heavy?
Well,
You talked about density, but didn't say per pound.
I'm going to
But
make a small apology up front, and that is I have a lot of videos, and there's going to be some overlap, but I think that that's going to be answered in later on in another video.
All right, I'll shut up. Bob has his hand up.
Hey, Bob.
I'm just wondering how this might affect Tesla's battery storage business.
Well, it's obvious
Is
that they're
it-
going to switch to it. I mean, I think that there's no reason why they wouldn't. I mean, if it's the same, and as they mentioned, if you have a process, a manufacturing process for doing lithium ion batteries, switching that over to sodium isn't going to cause you to have to set up a new factory. You can pretty much do it in the same. Well, I mean, I'm sure there's going to be some tweaking, but it's going to be.
So, so
Yeah.
it will decrease the cost and probably increase the volume of use of these storage facilities, which may, in fact, in the long run, increase the profitability, as well as the penetration of these storage facilities around the world. Is that logical?
Well, if you I can bring this up, and I can show you this. I did a search online for something like this. Let me bring this up and I'll talk about it a little bit. I'm just going to do
Thank you.
another share. Um, this is something I'm going to give all of you that are on my list. I wrote this question to Gemini, given solar, wind, and sodium and ion batteries and iron air batteries. So I'm saying that there's this, so you got solar, you got wind, sodium ion batteries, and iron air batteries is 24/7 power at its most reasonable cost. So what I'm trying to say here is it's going to be a menu of things that you can do for storage, which can be brought together. And of course, AI is always going to try to give you a happy answer. But it said combining wind, solar, sodium ion, and iron air represents one of the most economically viable pathways to 24/7 carbon-free power. Rather than competing these technologies can serve in a complementary duration and grid functions together, minimizing the total cost of firm, round-the-clock renewable energy, solar, wind, and so forth. So basically, what you get with sodium ion is a longer storage than lithium ion. And then the iron air battery takes you up to almost 100 hours or 4 days of power. So it's going to be a menu of options that can make a difference for grid storage.
Thank you.
That help, Bob?
That's fine. Thank you, Stan.
Anybody else?
I just posted that sodium is 3 2/3 times heavier than lithium. Atomic number 11 versus atomic number 3.
Say that again.
Sodium is almost 4 times heavier than lithium.
Okay, 4 times.
Right, but what percentage of a sodium ion or lithium ion is sodium and lithium? 10%, 20%, 90%? You see what I mean? There is more than just lithium in there. There's electrolytes and carbon and whatnot. So
Yeah, but we were talking about sodium versus lithium.
yeah, but I mean that you're saying that lithium and or sodium is a major piece of the weight, yes? But you know, which I'm not going to argue with.
There are other elements involved. You're right.
Carol wanted to say something. Carol?
Carol,
Yes. The relative atomic weights don't count for what you're looking at. Because the lithium ion is tiny, the sodium ion is big. So as far as weight packing density, that affects it more than the relative atomic weights of the elements. That's what I was trying to get into this conversation while also trying to post. You know what I'm saying? It
Yes.
doesn't matter what the relative atomic weights
Well,
are.
yeah, it does. It's one of the main factor. The size, according to the last video, the size of the sodium ions was larger than the lithium, but not twice as big. It could almost fit in graphite, but not quite.
Okay, but you have to look at the overall density to get weight.
I was just
Yeah.
answering someone's question.
I may be naive here, but if these are stationary storage units, does it really matter how much the weight is? They'll just move. They may need more space or something, but they're stationary.
Yes, that's why they
Exactly.
were saying that their application is for the large grid stationary type storage, not so much the
Absolutely.
portable storage.
They're not going to sink to the bottom of the earth. Yeah, you have a good enough concrete pad, and they'll be fine. They weigh what they weigh.
okay, well, see if there's any more questions. I mean, and I do have my next video. Give me a couple of seconds here to get this rocking and rolling here.
But while he's cruising, to Tom's point, yeah, there's a reason they use spent uranium as an armor-piercing bullet, because based on its atomic weight, it's dense and heavy. So yeah, I have to assume that Tom is correct in that, in general, a sodium battery is going to be substantially heavier than the same capacity lithium.
I'd like to go right into the next video if possible. Carol, what's up?
Yes. One thing that they're not talking about taking into account with these massive sodium batteries all over hell and back is heat generation. Are these enough heat generation to the outside atmosphere? Are these things going to contribute significantly to global warming?
I'm just going to say no. I think if you're looking at that reminds me of someone arguing that we shouldn't use wind towers and wind power because it kills birds. It's you're going to have a downside maybe. I don't have numbers on that, Carol, as far as the actual release of heat from these batteries, but I think that it's not
Well,
gonna,
I wasn't worried about release of heat from batteries until you started talking about truck size batteries in football fields. I mean,
Yeah, Carol, if I might take a crack at that,
yes,
it depends on what you're comparing it with. The round trip batteries that they were talking about 90+%. So you're only losing 10% perhaps to heat, but you have to compare it with where else you might get the power. And if you're getting it from fossil fuels, you're looking at 65% losses to heat.
right, but you're not necessarily comparing it to fossil fuels, you're comparing it to other types of batteries.
Yeah, and that's absolutely correct in terms of wind and solar. If you can use it straight, you want to.
Look, I'm not panning the idea. I'm just suggesting that perhaps that should be included in your calculations.
The question is whether electricity is more efficient than the way we're getting our energy in general.
The way we're getting,
Where we're getting our energy for the end purpose. If we want transportation, we're going from fossil fuels to electricity. And solar, wind, and batteries is a far more efficient production of transportation than fossil fuels from oil or
yes,
diesel.
total agreement. But I don't think we should be comparing it to fossil fuels. We should be comparing it to lithium-ion batteries.
Well, yeah, and the point here is that the cost is still coming down. Lithium is running into some challenges related to supply chain.
Yes, only suggesting that this might become a big enough factor that you should include it in your total comparison calculations.
Okay.
Not trying to knock it out, just saying, have we considered everything?
I think I'm next. We'll move on quickly, but I just wanted to comment on what Carol said is that as I understand it, sodium ion operates better over a wider temperature range than lithium ion, and it's less likely to go up in flames, which would suggest that it doesn't get as hot as lithium ion, but I'm not positive of that.
So it's more efficient in a Minnesota winter than lithium?
That's my understanding. Stan's
Yeah.
talking, but he's muted.
I'm sorry, I did that meeting because I've got stuff prepared. These next two videos are going to be Dr. Ben Miles, and they're probably the better ones that I've got. So I think a lot of these questions will be answered in this particular video. So let's go ahead and watch this. So my appreciation for that particular video, which is probably one of the earliest ones that I came across, was that he did a nice job with his graphic support to really discuss the issue of where lithium ions, when they go into the anode with the graphite layers, just slide in there, no problem. You take the same ion with the sodium, it's going to start pushing the walls around, causing it to decay. So with the sodium, you've got the new recipe for the anode, which was this hard carbon recipe, which will allow for the sodium ions to come into it and to be able to do a nice job of making the charge work. And the outcome of that is that you get a battery that is more tolerant to hot and cold weather and is able to do charge cycling. There's the average, if you think about it, they're claiming that the charge cycling for sodium ion is going to give it close to a 30-year battery life. So you're looking at a product that you can sell in the storage for grid storage, that you can sell for storage, which is going to almost match the same duration that you're going to have for your solar panels themselves. So think about it, you're getting solar panels and storage that are going to be pretty much the same, have the same cycle life. Okay, any questions, comments?
And maybe I missed it, but did you do any direct comparison with iron air? I saw some of that in the beginning, but
Well, we've talked about iron air before.
yeah,
What I can tell you about iron air, and this is why I think that the total solution for grid storage is to do both sodium ion and iron air, because with sodium ion, you're going to probably get your 4 to 6, maybe 10 hours of coverage for when people come home from work, the sun's gone down, you've got a lot of draw on energy. But if you have another two layers in your stack for charge, you can have iron air, which is going to increase your duration up to 100 hours or 4 days.
right.
And between all of those, and then you can, so you're talking wind, solar, sodium ion, and iron air. I think that you're going to have that 24/7 potential for, and you know, and if you want to, you can still include some other natural gas or something like that as a backup. But I think that it's going to go. I think the sheer volume of purchases that they've already got for grid storage is demonstrating that this is going to basically be a game changer. I've got more videos. Anybody? Is anybody excited?
Everybody's quiet today.
Eric,
I'm excited. Yeah, I mean it's interesting, but it seems like we're doing two different lectures here. We're talking about grid storage on a concrete pad, and then we're suddenly talking about cars, and then we're suddenly talking about cell phones. But I think he's giving the context. It ain't for cell phones. We know that. We just want lithium that doesn't catch on fire, I guess, right?
right?
Eric the Hand has his hand up.
He's muted too. Eric, you're muted.
Tom, you're muted.
Eric?
Yeah, I understand that you can't get a replacement battery for existing tools, like a phone where the volume for the battery is tightly enclosed. But how about for ones where it's not, such as my drill? I already have multiple sized batteries for my lithium ones for my drill. So is there any reason they couldn't make a replacement one that's maybe a little bigger for the drill? Or is it big? Is it the total weight be? Was it you said density of?
You talking about power tools?
Yeah, or a snow thrower, a lawnmower, snow thrower. I'd have to rebuy all of those just to get a little more efficient battery.
Well, I would imagine for example, I have a Ryobi lawnmower. It's like
Yeah,
an electric lawnmower. It would seem to me that a smart individual engineering products for Ryobi wanting to use sodium ion batteries would be
yeah,
able to construct that
a replacement. Huh?
so it pops right into the
Yeah,
same.
that's what I'm thinking. As long as the volume where the battery goes, because I guess you said you'd need a bigger volume one for the same power for sodium is the only downside. Is that right?
Well, the
And
other,
if that volume's not constrained, like I already can fit multiple sized batteries on my drill, so it should be able to, somebody should be able to make a replacement sodium battery for that same drill. They're expensive. Like Makita drills, they're great, but they're quite expensive. I don't want to replace it just to get a little longer lasting battery.
I would say don't even worry about it. I
Yeah,
would say consider for hand tools, just keep using lithium ion. There's going to be plenty of that available. This
yeah,
sodium ion thing is, I mean, how many times have I heard people say, oh, but you don't get power when the sun doesn't shine and when the wind doesn't blow?
Yeah.
This is about the grid storage that's going to be able to make that argument go away.
Way. Totally.
well,
it
yeah,
won't go away for a handheld tool, which are the standard now. Everything is battery up. But
yeah,
anyway, but to Eric's point, well, why can't somebody come up with a sodium one? Well, is the charging circuitry going to be compatible with a
yeah.
totally different kind of battery? Probably not.
Well, you just plug it in. I mean, I'm sort of naive about this, but the thing I'm noticing is that the engineering required to make these on the manufacturing side
Oh,
is very similar between sodium and lithium ion.
fine.
And I would imagine that as far as the maintenance and charging on the consumer side is going to be very similar as well. Plug it in.
Yeah, but what you're plugging in has to change. You can't just use the same charger.
Correct.
Oh, okay. So that would have to buy new chargers then.
With the new batteries.
Yeah, that's a big downside, I guess, because they're expensive.
I'm not selling this process. This particular program. The title for this talk was sodium ion for grid storage. That's
Yeah,
that's
exactly. Why do we concentrate on that?
Well, because I don't have to buy a grid. I have to buy new
yeah,
batteries.
me too. And I think we're down to two good ones for our lawnmower,
Yeah,
6 amp hour or whatever. I
Yeah.
can mow the lawn twice on one battery.
okay. Just give me a minute. I'm going to stage this next video.
yeah,
Oh, but
Yeah.
let me point out, when we talk about cars,
yeah.
80% charge in 30 minutes. Well, it takes me 4.5 hours.
Mm,
So that is attractive, very attractive
yeah,
for electric cars. And maybe they're shorter range, right? And not as heavy, but who doesn't spend 15 minutes in Walmart? Come on.
Okay,
Yeah.
this is Ben Miles again. I'm sorry if you're tired of him, but I think this is also a pretty good video.
Yeah, if no one else objects, then can you turn on closed captions?
Oh, I'm sorry, Gene.
Because he's British. I don't speak British. I speak English.
Okay, I think I've got it turned on.
Here, I thought they hadn't spoken it for years.
Eric had his hand up earlier.
Oh, I guess I'm a little confused still about. You just said they're not competitive or anytime soon for things like cars, anything that moves. So we don't. I thought there was a lot of propaganda for them replacing lithium in cars, but now is there not? Which is projected to be the the better one for cars and the
Well, the one suggestion, okay, I did see the Nextra. They have the Tenor and the Nextra line. These are two lines of batteries. The Nextra is one for cars, and the Tenor is the one for grid. In the previous video, Dr. Miles said that there are some ideas about maybe having a half and half sodium and lithium in the same car, and then having the computer be able to get the best resource for the best for whatever conditions. But I'm going to sort of land back on the title of the discussion, which is called Sodium for Grid, because that's where I think it's really going to make a difference. Dean?
Yeah, I didn't lower my hand. Yeah, there's a lot to unpack here, Stan. But I see why you've been, Stan and I talk sometimes, and he's very, very excited about this. But as of today, Eric, to your point, sodium costs 80% more than lithium today. And then real quickly, I wikied CATL or CATL, and they were heavily subsidized by the Chinese government. And guess what? That's why they got really good at this stuff. So there's some strategic involved.
Oh yeah, they've gone deep into debt. I think they saw their debts are total like 3 times their GDP because the government's just invested massively in what they see most critical things like batteries and solar cells and so on.
Because the Chinese are smarter than we are. Go ahead.
Did you say the numbers were worse for sodium over lithium?
Yeah, I'm going to watch that video. Yeah, right.
Is that currently or projected if they get to mass production?
10 years or 20 years. But today, at the nascent thing of this technology, yes, they are more expensive. Will they become cheaper? No doubt.
Yeah.
Right. Well, it's just the case that manufacturing has always proven that if in the printing industry, if you want to print 1 or 2 copies of a magazine, it's going to cost a lot. If you want to do a couple of million, it's going to be very cheap per magazine.
The first cars were millionaires' toys, and then suddenly they became cheap.
Well, yeah, it was competitive for years at the 1900 or so between electric, steam, and gasoline. So I don't know if sodium has all these other advantages. I assume clever people will make it cheaper, the better overall to use. Clever,
David, you weren't done talking, right? You had your hand up.
Yeah. China subsidizes a lot of their manufacturing because they're trying to put 1 billion people to work.
Yeah. And beat the West at the critical industries, get us dependent on them by offering something cheaper now than we can buy or build ourselves.
Well, and they've then built a manufacturing ecosystem based on cheap energy that we can't compete with.
Right.
Plus, I think that China has if you're talking about maybe the NIMBY issue, I mean, for example, Dean, I don't know if you got this big, huge resource of lithium somewhere near San Diego.
We do.
Is that NIMBY issue going to come up as when you start?
Oh, are you kidding me? That's all they talk about. Yeah. What effect on the environment, et cetera, et cetera. Will the jobs go to Americans, et cetera?
I would have to say that China probably has, I don't know if they have numbers on this, but their NIMBY factor isn't nearly as severe.
What do you mean? If they want to build a Three Gorges dam, they don't care if they displace 3 million people. It means nothing to them.
Yeah.
I'll shut up.
Tom Walsh, you're muted. Tom Walsh is talking and you're muted, Tom.
Okay, we have about 20 more minutes and you have a lot of videos. So what else do you want to do?
I have two more videos that I have two videos that I have on schedule. And if it gets to that point, there's another one that I could probably find involving Rosie, the engineer, the Australian engineer. But I'm going to go on the audio. I'm going to cut my audio off for a second here and I'll get this next one ready.
While you're bringing that up, next week, Peter Bishop is planning to talk to us about affecting the future. That I expect to be interesting.
Well, we're affecting the future even as we speak, right? But no, I'm looking forward to it.
Can you go back and what is it we're looking at next month, next week?
Next week. Peter Bishop.
I am not hearing you.
Oh,
Peter Bishop, Affecting the Future.
Peter Bishop.
Okay.
Maybe that's just more of the same. But
he explained it in a slightly different way. And
the one thing that he did, that his graphic had the anode on one side and the cathode on the other. It was kind of a different from the other ones, but
oh yeah, he flipped it, yeah.
flipped the anodes.
I had a comment, never mind.
Go ahead.
No, I forgot, Stan.
Oh.
I derailed myself. We have more videos?
The last video that I have is 8 minutes, so yeah, we can do that.
Yeah, we're good.
Yep. And maybe if we're still done, this reminds me of 15, 16 years ago when my brother and I bought this house together and he switched me over to NiCad rechargeables. Oh, we're not going to go buy any more batteries. We're going to charge them all. Well, there's a big problem there.
Yeah.
They don't come in at 1.64. They barely come in at 1.5. And their lifespan in many devices is about 1 minute. Yeah. So there was a problem, but we gave them a shot.
That's good.
Okay, here we go.
I remembered my thought when I wikied CATL, CATL, Ford went all in on CATL batteries in their Mustang, which is a really nice car, what I've heard, and it just ain't the car I want to drive. And their F-150, ditto, which they've now suspended. But yeah, they are believing in the CATL, but those were lithium, no doubt. And Carol, and my other point, Carol, you missed it. You went somewhere.
Yeah, I went to get more tea.
The last guy answered your question. Sodium generate 50%. I wrote it down. Less heat.
Yep.
Lithium. I caught it.
The other thing about Ford, they have a new truck line they're starting called the Fathom. And
yeah, they're redoing the F-150 Lightning.
The design of it is very similar to, it's like a chassis, aluminum chassis, using the same strategy that Tesla's been using, with a chassis injection gigapress chassis in the front and the rear. So you have, and then you have the battery unit in the center, and it's structural. And so they're sort of getting their cells into the new, and this is going to be a mid-size pickup.
Just so they
midsize.
don't make it look like a Tesla.
Yeah, please do not make it look like a Tesla.
No, it's going to be kind of like the
Yeah, no,
Range.
I was testing the fast Tesla DC charger, and I went up and got a taco and said, okay, what can I charge? Oh yeah, I can charge my car 80% faster than a Tesla. I mean, faster than getting a taco. And the guy next to me had an F-150 Lightning, and he was a smart guy. We started chatting while we were charging, right? And I said, what do you think? He said, there's a learning curve to an EV. I said, tell me about it, my friend. Yeah, but see, overall, he liked it, but it didn't gain the traction. The Mustang, for some reason, I mean, they're all over San Diego. You see them all the time. Just look for a Mustang that doesn't make noise and doesn't have a grill. That's the Mustang E-Type or whatever they call it. Okay.
Yeah.
David?
I kind of wonder, it sounds to me like the GigaPress cuts the welding down a whole lot, but it makes it potentially much more difficult to repair after an accident.
Yeah.
Yeah, probably impossible to repair.
Repairs.
That argument came up a lot for Tesla, and I think that there's a crossover between when you get enough impact that it's damaged the chassis, or whether it's just a surface thing. One of the things that the Tesla people would say is that their cars are so packed with cameras,
Yeah.
and their response to be able to, if you can't avoid the accident, the car itself will sort of avoid the accident, that your collision percentage of collisions is going to be low.
Yeah.
And yeah, there's trade-offs in that respect. But
Yeah. I mean, that's an argument, but I see smashed up Teslas on the news every day in San Diego. So, because about 25% of the people drive Teslas here, it seems. But yeah, but my experience with cars, which is about 70 years, maybe more, is that once a frame is bent, you sell that to somebody else, and you go get a new car. Period.
Yeah.
The problem with Teslas was on the news today in Minnesota. They're ticketing, I don't know how many of them, for going over 100 miles an hour on the freeways.
How about front license plates? See, Teslas do not, you have to spend another $800 to have a front license plate. So I didn't put a front license plate on my Mini. I have it in the back somewhere, under the back seat or something. And if a cop ever pulls me over, and we used to get pulled over all the time in San Diego County for not having a front plate. And I said, all right, Mr. Officer, you write me a ticket and you show me how many Teslas you've written up today, because I don't see 1 in 50 that has a front plate. They look cooler without the front plate, I got to admit it.
Eric?
Yeah, I'd like to know, Dean, what the percentage of those Teslas that smashed are using version 14 or full self-driving, the latest, which I see the data for that is claiming 5.2 times safer than human drivers.
Yeah, no, I agree, and I can tell the people that are using self or assisted driving from the ones that are just winging it like they've always done, because you have both modes.
They see a lot of people now have said, "Oh, I tried that a couple of years ago and it wasn't good enough." But they were using like version 12. It's improved a lot and is getting better all the time.
Yeah, but a lot of these are probably older Teslas.
Yeah, some of the old ones they say can't use the latest version.
With the hardware and all that. No,
Yeah.
in my Mini, I use assisted driving a lot. I
Yeah.
love it. It
Oh.
helps me stay in the lane, maintains my speed, and then often I'll get around up one or two Teslas, and they're doing something similar. They may be full self driving, but yeah, no, it's a freeway that I love to drive on.
Yeah.
But yeah, I wish everybody had that, but you'd need a democratic socialist to buy everybody a self-driving car or assisted.
I get mad, Dean, when I hit that line that I shouldn't, and the car starts shaking and slowing me down.
Oh,
They'll be
So,
coming out with cheaper models.
no, mine doesn't complain when I speed.
oh, mine, I turned it off finally because it
Yeah.
just, it's just not often, but it's just enough to irritate you.
Yeah, no, even when I'm driving in full cruise control, distance control and lane control and all that, steering wheel chatter, and they put rumble bars. Somehow Tesla, I mean the Mini puts rumble bars on every lane. I'm getting off the freeway and it's rumbling the steering wheel, saying you're going off the road. I know I am. Thank you very much. I appreciate your input now.